Okay, so I thought that we could take a look at some of the problems that we did not do on that worksheet we were working on in class the other day. We had done up to, actually I think we did on the front side, we did maybe 5, 6, or maybe just 6, 7, 8, 9, and then you were to finish 10 for homework. I can't remember if we did 5 or not, but and then I've assigned these 4 problems for homework 11 through 14 for during week 19. So I thought maybe we would just take a look at some of these. I know that you had expressed some concerns about what do I do when that leading coefficient is not a prime? Like, aren't I going to get a ton of possibilities? So I thought maybe we could look through some of these and just see how that's going to play out. All right, so again, let's look first at 15. And again, regardless of the fact that this is a trinomial and the leading coefficient is greater than 1, we should always check for a GCF first. And thank goodness we do, because there is an extra r in all of these terms. This is not a harder general trinomial as it stands, because while this is squared and this is to the first, there's an extra r in there that doesn't belong in there. So the first thing I would do is I would pull that out. All right, so we've got r and then 9p squared plus 73p plus 70. Okay, now that is a harder general trinomial. Right, leading coefficient is not 1. There are 3 terms, and then the pattern of the exponents is that whatever the highest one is, the middle term, the exponent is half as big, and then the last term has no variable at all. Okay, I'm just going to set this r aside. And again, at the end, we'll have to remember to put it back in, but I really want to focus on this. Right, and so we know that from what we talked about in class on Tuesday, when we factor this, I know that I have to get 9p squared, which means I have to have 2 things that multiply together to get 9, and each of them has to have a single letter p in it, so that when I multiply them together I get p squared. So if I think about how can I get 9, I could do 1 and 9 or 3 and 3. All right, so again, here we're seeing we have 2 choices. On the first side of this page, we only had 1 choice because that leading coefficient was always prime. All right, and then we know that these last 2 terms are going to have to multiply together to give us a 70. All right, so I've got 1 and 70, 2 and 35. 3 does not go into 70 because 7 plus 0 is 7, and 3 doesn't go into 7. 4 doesn't go into 70 because 4 does go into 68, and it does go into 72, but not 70. All right, so then 5, yes, 5 does go into it because it ends in a 0. It goes in 14 times. 6 won't go in because the rule for 6 is it has to be divisible by 2 and by 3. 7 obviously goes in because it's 7 and 10. 8 won't go in because 4 didn't go in. 9 won't go in because 3 didn't go in. 10 does go in, and it's already listed here, so that's it. So we've got quite a few options here. 1 and 70, 2 and 35, 5 and 14, 7 and 10. All right. So we will have a lot of possibilities to list here. So I am going to list them just so that you get the practice doing it. All right, so first let's start with 1 and 9. So 1r and 9r. Then we've got 1 and 70. We also have 1r and 70. And 9r and 1. All right, so that and that have been paired together. Now let's do 1r and 2 and 9r and 35, or 1r and 35 and 9r and 2. Jinkies, this is going to take long. Okay. Then we've got 1r and 5, 9r and 14, 1r and 14, 9r and 5. Then we've got 1r and 7, 9r and 10, 1r and 10, and 9r and 7. All right, let's get rid of some of these that are not going to work. We still have to go back and do 3 and 3. That should be shorter though, because we're not going to have that rotation that we did, since the first terms would be the same. So let's just eliminate any that we can here. All right, we're trying to get to 73. If we think about the signs, this is nice because this is positive, so they're either both positive or both negative. But the sum is positive, so it has to be positive. So all of these, there's no guessing in this. It's always all positive. All right, so if I do this, I'm going to get 70 and 9, too big. I need 73. Here I'm going to get 1 and holy smoke, 630, way too big. Now I'm going to get 35 and 18, not big enough. Here I'm going to get, wow, again, 2 and very big, over 270. So no, that's not going to work. Right here I'm going to get 14 and 45. That's not big enough. This is going to give me, wow, really big plus another 5, way too big. Right, then I've got 10 and 63. Oh wow, look, that's it right there. All right, and then this would be 90 and 7, too big. Right, I encourage you, just for the practice, to write down the ones that go along with 3 and 3. I don't have room here to do that, but again, let me just do the first one. It would be 3r and 1 and 3r and 70. I don't have to do 3r and 70 and 3r and 1 because they're exactly the same, just the terms have been, or the parentheses have been reversed. So you've got half as many as you do here, but I encourage you to take the time to practice writing that out. So again, up here we had 1, 2, 3, 4, 5, 6, 7, 8 options. Now we're only going to have 4 down here because of the fact that those are both the same number, right? Okay, so you can't flip them around and get a different set. They'll just be exactly the same, but just parentheses in the reverse order. All right, so here it is. All right, and again, it's going to be plus and plus. And so we end up with r times, oops, I was doing r this whole time. It should have been p. Sorry about that. All right, so it's going to be p plus 7 and then 9p plus 10. Sorry, I hope that wasn't too confusing while I was writing r. Hopefully you realized I meant to be writing p. All right, so that would be it. Again, let's just double check it. So I get p times 9 is 9p squared. Then p times 10 is 10p. Then 7 times 9p is 63p. And 7 times 10 is 70. All that times r. So then I'm going to get r times 9p squared plus 73p plus 70. And when we distribute that r back in, we get right back up to here. So this is the factorization. All right, I'm going to come back to this one because it's a little bit nasty. So let's go to number 17. And again, let's notice that this is not a harder general trinomial as is, because x cubed is not twice the size of x squared. It's not that even multiple. But that's okay, because as I look at the terms, I do see that they all have an x. All right, so I'm going to pull that x out and get 4x squared plus 43x plus 30. Now I can say, oh yeah, that's definitely a harder general trinomial. I have that squared. The next one is half that big, it's a 1, and then the third term has no variable in it at all. Okay, and again, I've got to think I'm going to break this up into 2 parentheses. Again, fortunately, we've got this same plus plus right here. So all our parentheses are going to have addition in there. This one says that the signs have to either both be positive or both be negative. That's the only way I can get a positive product. Right, but then I have to add those either two negatives or two positives to get a positive. Well, I can't add two negatives to get a positive, so they must both be positive. All right, so these two terms right here are going to have to multiply to give me a 4x squared. So my choices then are 1 and 4 or 2 and 2. Now these two terms right here are going to multiply together to give me 30. So we've got 1 and 30, 2 and 15, or 3 and 10. Yikes. All right, so let's start listing some. Let's do the 1 and 4. Actually, let's do, since we didn't do the ones that were equal last time, like here we had the 3 and 3, we did the 1 and 9. Let's do the equal ones first, because there's some interesting things that happen that I just want to make sure that you see. All right, so if we do 2x and 2x, then I can have 1 and 30. Again, it doesn't make sense to do 30 and 1 like this, because it's exactly the same thing. I've just reversed the order of the parentheses, of the binomials. So it's because these first terms are identical in each parentheses that I don't have to do the switch that I did here. All right. So I'm not going to write this one because it's exactly the same as one I already wrote. All right. But I will go on to the next one, 2x plus 2 and 2x plus 15. And then the next is 2x plus 3 and 2x plus 10. All right, now, if you remember, we said if there was no GCF in this, no common factor between all the terms, then none of the binomials can have a common factor, because if they did, it would have been in here. All right, well, I see that these have a common factor, so that's not allowed. I see that these have a common factor, that's not allowed. And I see that these have a common factor, that's not allowed. So this cannot possibly happen. It must be the 1 and the 4. All right, so we've got x plus, all right, so let's go again. This is 4x. All right, so we've got 1 and 30. Again, I do have to reverse them now because the 4x and the x are different. So x plus 30, 4x plus 1. All right, then let me come up here. Then I've got x, and then x plus 2, 4x plus 15, or x times x plus 15, 4x plus 2, and then finally x times x plus 3 times x plus 4x plus 10, or x times x plus 10, 4x plus 3. Okay, so let's check to see which of these will work now. So as we go through, we're looking to see, again, we looked up here, we said there's no GCF, so it's not possible that any one of these factors has a GCF, just like we said here. Right, these two do have a GCF, so this one can't work. This one could potentially work because there's no GCF. There's no GCF here, so that's okay, but this one has a GCF, so no. This one has a GCF, so no. All right, so we're down to these. All right, we're trying to get a product of 40, or a sum of 43 out of our two products, so that staple is 120, so that is too big now. This is going to give us 8, and this is going to give us 15. That's not going to be enough, so that's not it. And here we go. We've got 40 and 3, and this is it. All right, let's just multiply that back out to just confirm. So we've got x times, that's going to give us 4x squared, plus 3x plus 40x plus 30, all right, coming from those two. So we've got x, 4x squared plus 43x plus 30, and if we distribute that x back through there, we're going to get right back to what we had there at the beginning of problem 17. Okay, let's take a look at number 18, and we're going to list all the factors. So again, it is a harder general trinomial, right? We've got 3 terms. We've got the leading coefficient is not 1, and then the pattern of the exponents is such that the highest one is twice this one, and then there's no variable in the last one. Okay, so we need to split this up into 2. And again, if we're thinking about what are our factors of 10, because these are what are going to multiply together to give us the 10m squared. So 1 and 10, or 2 and 5. And then for 9, we've got 1 and 9, or 3 and 3. So let's start with the 1 and 10. So we've got m and 10m. Right? Then we ask ourselves, we put 1 and 9 in here. Will it make a difference if we reverse? Well, yes, it will, because these two are not the same. So then I could get m and 9. And 10m and 1. Right, then I'm going to do m and 3 and 10m and 3. Will it make a difference if I reverse here? Well, no, because I'm going to switch them and they're still going to look exactly the same. So I don't get 2 different possibilities from this, just from when these are different. All right, so then that's it for 1 and 10. So let's try 2m and 5m. All right, so we've got 1 and 9. Do I need to reverse? Yes. So 2m and 9, 5m and 1. All right, and then we've got 2m and 3, 5m and 3. Will I need to reverse? Nope. Because as soon as I get, sorry, it's not the 2m and the 5m, it's the 3 and the 3. If I try to reverse them, it's going to look exactly the same. All right. So then let's go through and check our staples. Again, that's the middle term and the outer term right here. So that's going to give me a 9m and a 10m. There's no way I can combine them in any way to get 89. So no, that's not going to do it. Right here I'm going to get 90, and this is going to give me 1. That is our, I think that's it. All right, but let's just double check the rest of this. So this is going to give us 30, and that's going to give us 3. No way we can get 89. That's going to give us 5 and 18, too small. It's going to give us 45 and 2, too small. It's going to give us 15 and 6, too small. So this is it. All right. So then we have to say, how am I going to put the signs in? So we note first that this is a minus sign. And again, we've had this conversation here. We've had it in class. If I have a negative here, I have to have one positive and one negative. When I have one positive and one negative term, when I combine them through addition, they're going to cancel through subtraction, right? Because they're opposite signs. So I'm looking for 2 things that multiply to 9 that subtract, and we're going to get 89 out of that, the staples right here. And it's got to be positive 89. So here I've got 90 and 1. I need a positive 90 and a negative 1 in order to get positive 89. So our positive 90, this is where our 90 comes from. Again, I can't change the sign of the 10, so I have to make this a positive. And then I need a minus 1, and so it's going to be that. All right, so m plus 9, 10m minus 1. Let's just multiply out to just confirm that. So m times 10m is going to give us 10m squared. M times negative 1 is going to give us negative m. Positive 9 times positive 10m is going to give us positive 90m, and 9 times negative 1 is going to give us negative 9. These combine to give us the 10m squared minus or no, kidding, plus 89m minus 9. And so this is our factorization. Again, don't box that in. This is the factorization. That's what you're looking for. All right, again, you might realize, like when you see 10 and 9 and you see 89 and you realize that 10 times 9 is 90 and 89 is 1 away from that, you're probably going to be drawn towards this one right here. Right? But again, we're practicing writing these out because sometimes it's not obvious like that. So anyway, we're just going to practice a couple more with them where we multiply them out. Okay, last one, and this is the worst one. So again, 9, we've seen that a couple times, 1 and 9, 3 and 3. 56 has quite a few that we've got to look at. 1 and 56, 2 and 28. 3 does not go into 56 because 5 plus 6 is 11. 3 doesn't go into 11. 4 does go into 56. It goes in 14 times. 5 doesn't go in because it doesn't end in a 0 or 5. 6 can't go in because the rule for 6 is 2 and 3 have to go in, but 3 didn't work. 7 does go in. It's 7 times 8. 8 goes in. It's already on the list, so that's it. We're done. All right, so let's start listing. All right, so we've got x and 9x. We've got, so let's see, x and 9x. So let's do 1 and 56. Do I need to reverse? Yes, 56 and 1. Then I've got x and 9x with 2 and 28. Do I need to reverse? Yes. I've got x and 4, 9x and 14, or x and 4, nope, x and 14, 9x and 4. Do you notice this? Not a single one of these shares a factor with 9. And so we are going to have to list all of them. We can't, well, we won't be able to immediately cross off any. All right, so then x and 7, 9x and 8, x and 8, 9x and 7. Okay, so that was all of them that go along with 1 and 9. All right, now let's switch to 3 and 3. This part is going to be easier because we're going to have less repetition. Because as soon as I have these the same, it doesn't matter what, like reversing these won't make a difference. So I'm going to have 1 and 56, but I wouldn't write 3x and 56 and 3x and 1 because I've just written that, but again, I've reversed the order of the terms, or the factors. So don't switch them when any part of it is the same. All right, so then I've got 3x and 3x, 2 and 28, 3x and 4, 3x and 14, and then 3x and 7, and 3x and 8. All right, let's go through and do this. All right, so we need them, whatever the staples are, again, there they are, the outer and the inner, they're going to have to subtract to 7. All right, well, this is 56 and 9, too big. Wow, this is enormous. No, that's not going to work. All right, 2 and 28, that's going to give us, 18 and 28, that's going to give us 10, but we're looking for 7. All right, way too big. 36 and 14, closer but too big. Way too big. 63 and 8, too big. 72 and 7, too big. Humongous, no. Enormous, no. Right, then we've got 12 and 42, still too big. 21 and 24, that's very close, but 3, it's too small. We have written every single possibility and not one of them works. So this means, unfortunately, this one does not factor. Right? So again, I know the listing is a pain in the neck and we won't do it for long, but for cases like this where it doesn't factor, it's helpful to know that you're not going to get something, like you haven't missed anything. All right, so just we're practicing that to make sure you're good with that. Okay, so I don't know that that has consoled you at all, because you're going to end up doing these four for homework. And again, you are going to have to probably list, well, actually, these are prime, so that's not too bad. This one is going to have quite a few factors, but at least we don't get a lot from here. These you're going to have to do some work. This one's not too bad either in terms of the options. Okay, hope that helps. Wow, were you able to even see what I was just doing there? Yeah, okay. All right, bye.